You paid $40,000 for your electric vehicle, maybe more. And the single most expensive component in that car is something you're probably damaging right now without realizing it. The battery pack. According to Kelley Blue Book, replacing an EV battery can cost anywhere from $4,000 to $36,000 when your warranty expires. For some vehicles, like the Kia Niro EV, that replacement runs about $30,000, not including labor. But here's what most people don't know. You don't wake up one day with a dead battery. It fades gradually through thousands of small decisions. Decisions that feel responsible, but are actually speeding up degradation. Today, we're covering 10 proven strategies to extend your EV battery life. Some of these directly contradict advice you've probably heard from other owners or even from dealerships. And the last few tips? Almost nobody talks about them, even though they can add years to your battery's usable life. Let's start with the most common mistake. Tip 1. Stop charging to 100% every night. If you plug in your EV every night and let it charge to 100%, you need to hear this. Lithium batteries don't like sitting at full voltage. The damage doesn't happen during the charging process itself. It happens while the battery sits there, fully charged, for hours. Think of it like holding your breath. You can do it for a minute, but doing it for 8 hours every night would cause problems. That's what happens when your battery stays at maximum voltage for extended periods. Chemical wear accelerates inside the cells, and that wear is permanent. The U.S. Department of Energy's research shows that modern EV batteries last 12 to 15 years in moderate climates, covering between 100,000 and 200,000 miles. But those numbers assume you're not constantly stressing the battery at its upper voltage limits. Most manufacturers now recommend charging to 80 or 90% for daily use. Kia's official guidance states that even though a full charge gives you maximum operating time, it's never a good idea for overall battery lifespan. Tesla includes this in their owner recommendations. Nissan mentions it in the Area manual. Here's how to fix this tonight. Go into your vehicle's settings and set a charging limit. Most EVs built in the last few years let you do this through the touchscreen or a smartphone app. Set it to 80% for weekday charging. Save 100% for road trips when you actually need the extra range. The difference adds up. Over 8 years, charging to 80% instead of 100% can preserve thousands of dollars in battery capacity. You're trading 20 miles of range today for years of healthy battery performance tomorrow. And once you understand why voltage stress matters, the next tip becomes obvious. Tip 2. Shallow charging cycles beat deep discharges. Running your battery down to 5 or 10% before recharging feels efficient. You're using everything you paid for, right? Wrong. Deep discharge cycles put significant strain on the internal structure of lithium cells. Each time you drain the battery close to empty, you're increasing internal resistance. That resistance is what causes range to slowly disappear over time. Recent research from the SLAC Stanford Battery Center found something interesting. They studied how real drivers use their EVs compared to laboratory testing methods. Lab tests traditionally drain batteries close to zero and then recharge them to 100% repeatedly. But actual EV owners rarely do this. Most people charge overnight and drive short daily trips, never approaching full discharge. And according to the Stanford research, this real-world usage pattern could make batteries last about a third longer than traditional testing predicts. The lesson here is counterintuitive. Charge more often, but in smaller amounts. If you get home with 60% battery remaining, go ahead and plug in. You're not wasting charge cycles. You're protecting the battery by keeping it in its optimal operating range, which is roughly between 20 and 80%. Think of it like eating throughout the day versus starving until dinner. Smaller, more frequent top-ups keep the battery healthier than letting it run down and then gorging it back to full. This doesn't mean you need to obsess over every percentage point, but if you've been deliberately running your battery low before charging because you thought it was better for the battery, you can stop. The opposite is true. And speaking of charging habits, there's one type of charging that deserves a much more nuanced conversation: Tip 3. DC fast charging isn't the enemy. Heat is. You've probably heard this warning. DC fast charging destroys batteries. Don't use it unless absolutely necessary. That's only partially accurate, and the missing context matters. Fast charging generates heat. Heat is what causes degradation. But occasional fast charging won't ruin your battery. The problem is frequent fast charging, especially under the wrong conditions. Kia released data showing that regular DC fast charging can reduce battery life by roughly 10% over 8 years, compared to slower level 2 charging. 10% is real, but it's not catastrophic. If you're on a road trip and you need to fast charge 3 times, your battery will be fine. Where people get into trouble is using fast charging as their primary charging method. If you're hitting a DC fast charger multiple times per week because you don't have home charging, that's when the cumulative heat damage stacks up. Here's the detail most people miss. Charging a hot battery makes everything worse. If you've just finished a long highway drive and your battery pack is already warm, immediately plugging into a fast charger compounds the heat stress. Many newer EVs will actually throttle charging speed when the battery temperature is high, which is the car protecting itself. The smarter approach? If you're on a road trip and about to fast charge, give the battery 10 or 15 minutes to cool down first. Get out, stretch, use the restroom, grab coffee. Let the battery thermal management system do its job before you plug in. Also, in cold weather, Nissan and other manufacturers recommend turning on the battery heater 30 minutes to an hour before fast charging. This brings the pack up to optimal temperature and allows it to accept charge more efficiently without stress. Fast charging is a tool. Used occasionally and intelligently, it's perfectly safe. Used carelessly, it accelerates wear. The difference is understanding when and how to use it. And if heat during charging matters this much, you can imagine what sitting in heat does. Tip 4. Parking in the sun is slowly killing your battery. Cold weather slows batteries down. You've probably noticed reduced range in winter. But cold doesn't age the battery. It just temporarily reduces performance. Heat ages batteries. When you park your EV in direct sunlight on a hot day, the battery pack temperature rises well above ambient temperature. Even after you walk away, that heat continues breaking down the chemical bonds inside the cells. This happens gradually, invisibly, and cumulatively. The Nissan Ariya manual specifically warns against storing the vehicle in temperatures below -13 degrees Fahrenheit for more than 7 days. But it also cautions against extended exposure to extreme heat. If you have access to a garage, use it. If you don't have a garage, park in shade whenever possible. Even a carport or a tree makes a measurable difference over years of ownership. This matters more in some climates than others. If you live in Phoenix or Las Vegas, parking habits can be the difference between a battery that lasts 12 years and one that shows significant degradation in 8. Research has shown that EVs used in hot climates degrade faster than advertised, and much of that comes down to sustained high temperatures. Some EVs like Tesla's allow you to remotely control cabin temperature through a smartphone app. Use this feature before you drive. Preconditioning the cabin while the car is still plugged in means you're not drawing power from the battery to run the air conditioning immediately after you start driving. This reduces initial load on the pack and helps maintain range. The principle here is simple. Heat is the enemy. Minimize exposure whenever you can. And once you start thinking about heat management, your driving style becomes relevant in ways you probably haven't considered. Tip 5. Aggressive driving creates invisible battery stress. Instant torque is one of the best things about driving an EV. Stomp on the accelerator and you get immediate, smooth power. It's addictive. But every hard acceleration spikes current flow through the battery. That current creates heat. And as we've established, heat accelerates degradation. This doesn't mean you need to drive like you're transporting nitroglycerin, but it does mean that constantly using launch mode or aggressively accelerating from every stoplight has long-term consequences. Smooth acceleration and consistent highway speeds are kinder to the battery. The difference isn't huge on any single drive, but over 5 or 10 years, driving style impacts how much internal resistance builds up in the cells. Think about it this way. If you owned a high-performance gasoline car, you'd understand that constantly redlining the engine shortens its life. The same principle applies to EV batteries. They can handle high output, but constantly demanding maximum performance creates wear. There's a balance here. You bought an EV partly because of the performance. Enjoy it. Just don't treat every green light like a drag race, especially if you're planning to keep the car for a decade. And while we're talking about how you drive, there's one feature that affects battery health more than most people realize. Tip 6. Regenerative braking settings matter more than you think. Regenerative braking captures energy that would otherwise be lost as heat and puts it back into the battery. It's one of the efficiency advantages of EVs, and it works brilliantly. But here's what's less discussed. Overly aggressive regenerative braking creates thermal spikes, especially in stop-and-go traffic. When you're in heavy city traffic and constantly decelerating, the energy being dumped back into the battery generates heat. If your regen settings are maxed out, you're cycling more current through the pack than necessary, which increases thermal load. Balanced regenerative braking settings reduce stress while still improving efficiency. Most EVs let you adjust regen intensity. You don't need to turn it off, but you also don't need to keep it at maximum all the time. Some drivers prefer one-pedal driving with maximum regen because it's convenient. That's fine for daily use, but if you're in situations where you're doing a lot of braking, like descending a mountain pass or stuck in urban gridlock, consider moderating the regen setting temporarily. This is a small adjustment that adds up over time, especially combined with the other habits we're discussing. And speaking of small adjustments that add up, there's one thing built into your car that actively protects your battery, and most owners completely ignore it. Tip 7. Software updates are battery health updates. Electric vehicles don't need oil changes. They need software updates. Manufacturers regularly send over-the-air updates that improve battery management systems, refine thermal controls, and adjust charge curves. Some of these updates are explicitly designed to slow degradation in aging battery packs. Skipping updates means missing out on improvements that could extend your battery's life, and because many of these changes happen in the background, you won't even notice them. The car just manages the battery more intelligently. Tesla has been doing this for years. Other manufacturers are catching up. In some cases, automakers have pushed updates that reduce stress on older batteries automatically without announcing it publicly. The fix is simple. Enable automatic updates if your car supports them. If not, check for updates monthly and install them when they become available. This takes 5 minutes and could save you thousands of dollars in avoided degradation. Your EV is essentially a computer on wheels. Treat it like one. Keep the software current. And just like you wouldn't let your computer sit unused for months without consequences, your EV battery doesn't like sitting idle either. Tip 8. Long-term storage will wreck your battery if you do it wrong. Let's say you're going on vacation for 3 weeks, or maybe you have a second vehicle and the EV sits for extended periods. How you store it matters enormously. Leaving your EV parked at 100% charge for weeks is one of the worst things you can do. The battery sits at maximum voltage stress the entire time, accelerating chemical breakdown. The ideal storage charge level is between 40 and 60%. This keeps the battery in a low-stress state while still maintaining enough charge to run the onboard systems that prevent the 12-volt auxiliary battery from dying. Temperature matters here too. If you're storing the vehicle in a hot garage at full charge, you're combining two of the most damaging factors. According to multiple manufacturer guidelines, including Nissan's, you should avoid storing vehicles in extreme temperatures for extended periods. If you're going to be away for more than a few weeks, plug the car in, but set the charge limit to 50%. Many EVs, including Tesla's, let you control charging remotely through an app. This lets the battery management system maintain optimal conditions without overcharging. Some batteries lose more capacity during improper storage than they do during active daily driving. That's not an exaggeration. 3 months of sitting at 100% in a hot environment can cause more damage than a year of normal use. Plan ahead. Store smart. And while we're talking about preparing the battery for specific conditions, there's one feature that protects your battery every time you use it, but most people think it's just about comfort. Tip 9. Preconditioning isn't just for your comfort. Most EVs let you precondition the cabin before you drive. You can heat it up in winter or cool it down in summer while the car is still plugged in. Most people use this feature because it's nice to get into a comfortable car. But preconditioning does something more important. It prepares the battery itself for optimal performance. Charging or driving a cold battery increases stress. The chemical reactions inside lithium cells slow down at low temperatures, which means the battery has to work harder to deliver or accept power. Preconditioning warms the pack to its ideal operating range before you even unplug. The same principle applies in hot weather. If the battery is already hot from sitting in the sun, preconditioning can run the thermal management system to bring the temperature down before you drive. Tesla specifically recommends using the scheduled departure feature to precondition the battery before trips. This isn't just about range, it's about reducing stress on the pack during the initial minutes of driving, which is when temperature-related strain is highest. Use this feature regularly, especially before long drives or before fast charging. It's built into the car. Take advantage of it. And now we get to the most important tip, the one that actually makes the biggest difference in real-world battery longevity. Tip 10. Stop obsessing. The best battery habit is psychological. Here's something nobody tells you about EV ownership. The people with the healthiest batteries aren't the ones following every rule perfectly. They're the ones who've stopped obsessing over range and charge percentages. They charge when convenient. They avoid extremes. They let the car's built-in systems do what they're designed to do. The owners who drive themselves crazy trying to squeeze every last percentage point of efficiency, they often end up with worse batteries. Because they're constantly monitoring, constantly adjusting, constantly stressing about numbers, and that stress leads to inconsistent habits. Here's an example. Someone becomes convinced they should never fast charge, so they plan elaborate routes to avoid DC chargers, even when it means letting the battery run dangerously low. They arrive home at 8%, plug into their level 2 charger, and charge back to 100% overnight. They've just done two of the most damaging things, deep discharge and extended time at full charge, because they were trying to avoid one instance of fast charging. The irony is brutal. Modern EV batteries are engineered for normal use. The cars have thermal management systems, charge controllers, and software that actively protects the battery. Your job isn't to outsmart these systems. Your job is to avoid the obvious extremes and let the car do its work. Charge to 80% most of the time. Avoid sitting at 100% for days. Don't deliberately run it to empty. Park in shade when you can. Keep the software updated. Precondition before driving in extreme temperatures. Do those things consistently and stop worrying about the rest, because the greatest threat to your battery isn't one wrong decision. It's years of anxious micromanagement that leads to worse habits than just driving normally. Your EV battery is going to degrade. That's unavoidable. Chemistry doesn't care about perfection. Hit that like button and subscribe for more honest automotive insights based on actual data.